Okay, here's a nice question. It's asking how many moles of ions will be present in that volume of that molarity of sodium phosphate. Okay, so C equals N over V. They want to know moles. So I'll multiply both sides by V. So moles is equal to C times V. Concentration, 0.450. Molar, so that's the same as moles per liter, times the volume, better convert that to liters, 0.716 liters. Liters cancel out, so let's times that. Okay, 0.450 times 0.716. Okay, 0.3 and a bunch of twos. 0.3222 moles. Now that's moles of sodium phosphate. So that's Na, okay, phosphate's PO4. It's a 3 minus, sodium's a 1 plus. We need a 3 there. So it's sodium phosphate. But they want to know the moles of ions. So now what I need to do is I need to write a dissociation equation. Let's do that over here. So I have Na3PO4, and that's some kind of solid that I have. If I dump it in water, it will dissociate, and it is dumped in water because it says aqueous up there. So it'll dissociate into sodium ions and phosphate ions, which will also be aqueous. Now balancing, I guess I need a 3 right there. So I have this many moles, 0.3222 moles of sodium phosphate. So for sodium, I'm going to have triple that. So I have to times that by 3. So that'd be 0.9666 moles of sodium. And phosphate, since they're the same, both 1, it'll just be 0.3222 moles of phosphate. And then they say how many, I should have written total. How many total moles of ions will be present? So you just add those two. So 0.9666 and 0.3222. And I get 888, 12, 1. 1.2888. So over here, looks like I have 3 sig figs, 3 sig figs. Let's give them 3 sig figs, so it'd be 1.29 moles total. I'm picking that one. Hopefully that helps you with that question. We'll be doing some more of those in class tomorrow.